Okay, see Lindelof videos establishing a trig identity, number 87. My God. Okay, so we talked about this a bunch, and I get a lot of mail from you guys, and that's great. Just want to remind you before we go on, this is what happens with your professors. Your professors do all these problems beforehand, so they seem like these flipping geniuses. Before we go on, I want to admit to you that when I looked at this, I wasn't sure where I was going with it, and I had to really sort my way through it. I do have it figured out, and I'm going to show it to you, but I just want to remind you that this is difficult, man. And okay, here we go. So we have 1 plus sine theta plus cosine theta over 1 plus sine theta minus cosine theta is equal to 1 plus cosine theta over sine theta. The first thing I would say to you is that one thing I would do is I would just cross multiply before I started the problem to make sure that you really agree with that actually works. I did do that. The identity holds up. Now I have to prove it. Keeping in mind this is a really difficult example, and also keeping in mind that this is a left-hand proof, therefore we cannot touch the right-hand side. All we can do is manipulate the right-hand side. So I noticed that these things are weird conjugates of each other, the numerator and the denominator, so I'm looking at this as if this is a plus b, and that makes this a minus b at the bottom. So I think what I'm going to do is I'm going to multiply by the conjugate of the denominator. So the conjugate of the denominator is 1 plus sine theta plus cosine theta over 1 plus sine theta plus cosine theta. All good? So remember conjugate, if we have a plus b, its conjugate would be a minus b. So I'm using this to develop a difference of squares. This kind of turns out really messy, so you have to really, really think your way through this a ton. So when I do this out, what I am going to do is I'm going to do FOIL, so I'm going to do this times this, which gives us 1 plus 2 sine theta plus sine squared theta. But then we have to do this. So this times this is cosine theta times 1 plus sine theta. I'm not going to move that in. It's just going to confuse the hell out of me. Then I'm going to do the inner. So that's the outer. Then I'm going to do the inner. And it gives me another one of those. So if you don't mind, I'm just going to call that 2 of those things. And then lastly, I have cosine theta times cosine theta is cosine squared theta. And I did do my FOIL, so I want to make sure that you see that I actually went through all of that. All right? I'm going to do exactly the same thing at the bottom. The bottom is difference of squares, so it's going to be a little bit easier. I'm going to get this times this is 1 plus 2 sine theta, isn't it? Plus sine squared theta. And then remember we have difference of squares, so this times this and this times this are opposites of each other, so that helps. And at the end I'm going to get minus cosine squared theta. So remember, the reason that I had no middle term is this is DOS, difference of squares. Alright? So pushing our way through all this crap. I'm going to start looking at what I have here. I'm going to start seeing if I can get some stuff put together. I'm going to use Pythagorean identities here and here, I think. So this is a Pythag ID here. And this is a Pythag ID here. So what I'm saying to you is I'm going to use replacement values for them. So we know that cosine squared theta have specific values. So in a second I'm going to go ahead and replace those, and you'll see why in just a second. So let's just go through it. So I'm going to rewrite. Remember, all this crap has got to be equal to the right hand side, and I can't touch that. So there's that. So I'm going to have to rewrite all this crap. 1 plus 2 sine theta plus sine squared theta plus 2 cosine theta 1 plus sine theta. I know it looks like crap. Hang in there. Plus, and then I said I was going to use this Pythagorean identity, and I know that cosine squared theta is equal to 1 minus sine squared theta. So that's my Pythagorean replacement on this one. I'm going to do the same thing at the bottom. I'm going to rewrite all this crap. I'm going to have 1 plus 2 sine theta plus sine squared theta. This negative sign is this one, but in parentheses, think about it, we have this. We have 1 minus sine squared theta. Here I'm going to simplify. I got a bunch of this today. They're like, can I cancel these? These are add-ins. These things are being added. You can't cancel add-ins. You can only cancel factors. So when you start to think, oh, maybe I'm going to cancel something, ask yourself, what's the relationship between the two things? If they're factors, cancel. If they're not factors, you can't cancel. So please think about that. It's a really, really common error that's made. All right, so I am going to start putting this together a bit. So we have 1 plus 1 is 2, isn't it? So we have 2 sine squared theta, negative sine squared theta goes away, doesn't it? So these two things cancel out, and that gives us 2 plus 2 sine, I'm in the numerator now, 2 sine theta plus 2 cosine theta, 1 plus sine theta. I know that's bothering the hell out of you, but hang in there for a second, it's going to work out. Over, same thing here, these ones cancel, don't they? This goes to negative 1, so this one and this one cancel. This is negative times a negative, this becomes a positive, so we have 2 sine theta, right? There's 2 sine thetas here. Sine theta plus sine squared theta plus sine squared theta is 2 sine squared thetas. Remember, they have to match in function and in exponential value for them to be added together. And that gets me there, I think. Yes, it does. And remember, it has to equal all this crap here. 1 plus cosine theta over sine theta at the bottom. So, where does that leave me? I guess I'll factor here and here. So it gives me 2 times 1 plus sine theta, right? Plus 2, that's this 2 right here, 2. If you don't mind, I'm just going to move this cosine to the back. I almost said to the ass, whatever you want to describe that. 2 sine theta, cosine theta. All I did was change their position. They're factors, so I can put them any direction I want. Just changing their direction just for a second so you can see this more clearly. At the bottom, I'm going to, if you don't mind, I'm going to go ahead and factor this thing. You know what, let me just turn them around. Let me put the 2 sine squared theta out front first. 2 sine theta plus 2 sine theta. Hopefully you're getting better at seeing that. This is where it gets a little bit weird, because I'm going to factor this whole thing. I'm going to factor out 2 times 1 plus sine theta times 1 plus cosine theta. Don't freak out. Just hold on a second before you get all freaked out about this. Look at this for a second. If I multiply, look, this is 2 times sine. That gives me that back, doesn't it? And if I multiply this into here, I get this, don't I? I get this sine here is this one, right? So it does work out good, I think. Now let's factor out the bottom, and from the bottom we can factor out 2 sine theta times sine theta plus 1. Can we agree that sine theta plus 1 is the same as 1 plus sine theta? 1 plus, just so we can look at it better, 1 plus sine theta, and it has to equal all this crap on the right hand side. And if you remember, that was 1 plus cosine theta over sine theta. And then look, it starts to get better. It starts out really bad, then it gets better if the 2's cancel, don't they? 1 plus sine theta's canceled, and we end up with this. So check mark, done. I know this stuff is really, really rugged. I worked on this for some time, I admit. It didn't come automatic. I didn't just look at this and have an answer. That would be disingenuous of me and of your professors who come off like they can see all this crap in their head so easily. So let me just tell you, there are tons of ways to do this stuff. As long as your math and your trig are good, you're going the right direction. And if you're saying, Charlie, I didn't go the same direction, you don't have to go the same direction. You just have to keep moving and look for ways to substitute trig identities. All right? So I hope this was helpful. If you haven't already subscribed, please do. I appreciate it.